when you get these questions on the test, then just start singing and dancing and rejoicing, because these are really easy. And what we've got to think is, what's going to happen to each of these numbers as we plug in a massive number for x, in other words, an infinite number? Well, right here, this one and this one are going to become pretty much irrelevant, because x is going to be so big that the only thing we're really interested in is this part of the statement. And what's going to happen is the two x's are going to cancel, and we're pretty much going to be left with negative 6 over 5. So that's the limit there. Next one along is same kind of strategy. Think about the most dominant terms in the top and the bottom, okay? That's the most dominant in the top, and that's the most dominant in the bottom. And when we write 3x squared over negative x squared, and we reduce that, well, the x squareds cancel, and we're going to be left with negative 3. And then the last one, think about dominant terms top and bottom. Well, that's the dominant on the top, dominant on the bottom, and that's x squared over x, which is equal to x, and if we plug in x equal to infinity, then that's going to be infinity, or in other words, limit does not exist. Okay, a few more, or a couple more here. Let's just change colors. So, well, this one's pretty simple, because as we plug in a massive infinite denominator, that basically chases the entire limit down to 0, because any number divided by infinities is going to give us 0. And then over this side we have to think a little bit more. I would just break it into 2 and say, alright, what about this right here? When we plug in infinity into a denominator, we're going to get 0 minus, and then that's the most dominant on the top, that's the most dominant on the bottom, so that's basically going to be 5x over x, which simplifies to 5, so we're left with negative 5. This looks a little bit different. You're going to be asked to find the limit if it exists, and this is just like the last question. All we're saying is let n go to infinity. So again, we pick the most dominant terms, basically that's in the top and that's in the bottom, which simplifies to 1 over n, and as n goes to infinity, that's going to give us a limit of 0. Here we've got that on top and that on bottom, which when you simplify 4n squared over 2n, that simplifies to 2n, doesn't it? And as we plug in n equal to infinity, that goes to infinity, which means the limit does not exist. And then finally this one, that's the most dominant, that's the most dominant. So we get 4n over 5n, the n's cancel, and we're left with 4/5. So now we're going to switch to the calculator portion of the test, which is quite short, sadly for you, because I know you love using calculators. You're going to be asked to find this limit, and the question is going to say, can you fill in the table? Now, I don't actually like the values that they use in this table, because I've shown you a different way of doing this. But let's just get this information into the calculator. So here's my calculator, and as you can see, if you compare the function they've given you, I've already plugged that into y equals. Now what I've told you guys to do is, I've said, okay, now let's go to second table set, and oops, lost my calculator, where's it gone? Second table set, and give it a start point. Well, the start point is going to be whatever your limit is. So our limit is negative 4, that's the point we want to go with. And then the difference table, I've said just pick a small number like 0.00. Did that work? I don't think that worked. 0.00. I'm not convinced that point is going in for some reason. Maybe you have to do 0. Yeah, that's how you do it. 001. And when we go to our table, we'll see it's quite obvious what the limit is going to be. Hopefully you can look at that screen and see that the limit is definitely going to be 1/2. Okay, it's clear from that. The problem is, let's just go back to that. Now if you look at the calculator, can you see that the values that the calculator is giving us are not the same as each one of these values right here? Now in the test, if they give you different numbers here than the ones in your calculator, don't panic. I don't care if you fill this table in the test. I just want to make sure that you can get to that correct limit. So if in the test they give you this function and they say, can you find the derivative using the limiting process, all that's asking is for you to go through that process of plugging it into the formula, which was f of x plus h minus f of x all over h. Oh, and don't forget the limit as h goes to 0. Alright, this one, let's see here. Write, but do not evaluate the limit. Oops, where did that go? Write, but do not evaluate the limit that would determine the slope at any point. Again, all that's saying is find the derivative, but in this case you don't actually have to keep going and work out what it is. So for this first one, let's just do this one here right now. Okay. So if we were going to plug that in using the limiting process, we would say, well, that is, well, let's just write our formula first. Okay, remember this: limit as x goes to h goes to 0 of f of x plus h minus f of x all over h. And literally all we're doing for each one of these questions is saying, okay, well, let's start with this one right here. That's my f of x. So the answer would be the limit as h goes to 0 of f of x plus h. So plug in x plus h, which would give you tangent of x plus h minus tangent of x all over h. And that's it. You stop there. You are finished. You don't have to do anything else. So now let's do this one. Well, that's going to be the limit as h goes to 0 of e to the power x plus h minus e to the x all over h. I don't think I even need to finish this one here. It's pretty plain what you do in this question.